All right, so today we start talking about real valued functions of several variables. Um, so a function f of two variables, um, a function f of two variables on a subset D of R2 is a rule that assigns to each element xy of D exactly one real number, which we denote by f of xy. And a function f of three variables on a subset D of R3 is a rule that assigns to each element xyz of D exactly one real number, which we denote by f of xyz. D is called the domain of the function, and the range of f is the collection of all values of f. So if I have a real valued function of two variables, then the domain of the function would be a subset of the two space, and the domain is the set of all input values, and then for each point in the domain, the value of the function f of xy is a real number. And so f is a function that assigns to each point in its domain exactly one real number denoted by f of xy. So the range is a subset of the set of real numbers here, and the domain is a subset of R2. If I have a function of three variables, then the domain would be a subset of R3, and the range here is a subset of the set of real numbers. So here the function assigns to each point in its domain exactly one real number, which we denote by, so the value of f at xyz is denoted by f of xyz. The notation I'm going to use here is f colon d arrow r. So this means that f is a function defined with domain D, and the values of f are in the set of real numbers. So this is a real valued function defined on the domain D. A function of n variables is defined similarly. So in this case, f would be a function from D to R where D is a subset of R to the n. Okay, so in the next video we will look at some examples.